Welcome everybody to ARCI's number 9 video meeting. It's the 20th of March, 2021, and we have a full agenda today, and I'm glad to be here to be the moderator for this meeting. You can see the agenda that we have up here today. And the first thing we're going to do is I'm going to give you a little introduction to the meeting and the protocol. And that's on this slide. And we've got a great turnout today. I can see that we've got over 34 people logged on. I think our registration sheet is over 50. And I'd like to welcome all the people from all over the country that have joined us here today. It's great that all these people from all these different clubs come and join us today. In fact, one of our presenters today is from the Colorado Club. And I'd like you to all consider being a presenter, because this is a great opportunity to share what you know about radios and some of your collection and that sort of thing. So consider it, and there'll be a poll question at near the end of the meeting where you can indicate your desire to do so. Our next meeting is about a month from now on April 17th. So these are regular meetings, so be ready for the next one too. And we have a group of us that welcome your feedback, and you can see the email event, remote events at antiqueradios.org. You can give us some feedback, ideas, and that sort of thing. And as you probably heard, this is being recorded. And as you may or may not know, this is recorded and put on YouTube. And Matt will talk about that in a minute. The protocol here today is pretty simple. If you're not presenting, stay on mute. And the presenters have a prearranged time to kind of get done with what they're trying to talk about. And if you do want to do a show and tell, you get about 3 minutes. So that's kind of the rules. And I'll turn it over to Matt now so he can give you his presentation on YouTube.
As you know, we are recording, and the reason we do that is to put our meetings on YouTube so that those who can't be here with us today can see it on YouTube. So what's up there? I'm proud to be able to tell everyone that every one of our online meets to date are now on YouTube. So this is number 9. We have 8 online meets. They've all been edited. And I will venture to get a online meet onto YouTube before the next online meet. So give me a month. It takes a ridiculously long amount of time to edit them. If you want to be updated about when they get posted, subscribe and click the bell for notifications. I'm sure you've all heard that a billion times from YouTube views. Some of our stats, these are from a couple days ago, so they've actually gone up, but we've had 677 views of our material, 114 hours watched, 70 subscribers, and almost 9,000 impressions, which are times when YouTube is showing thumbnails of our content to others. Since it is a public forum, there's a handful of considerations. Some are related to YouTube rules, some are just common sense. Agendas do list the full names of presenters unless you ask us not to. The recordings that of the Zoom meeting do not include the names. If you don't want your email seen to all of YouTube, then don't put it in your presentation if you're doing one. If you're sharing semi-confidential information like directions to your house, private links, contact information, the best place to do that is with the chat. In the chat, it's a good idea near the end of the meeting to hit the save chat button. That way you don't have to write it all down. You may hear me starting and stopping the recording. We don't record the for sale, for example, because that's kind of silly to get late. It's very important that you don't have any copyrighted materials present, especially music. If you're demoing a radio and you're doing band scans, YouTube is wicked fast in recognizing copyrighted music and giving us a copyright strike. So please don't do that. And nothing that's already on YouTube. This needs to be original material. The basic item is respect the forum. It's not a club business meeting. Everything we do is either semi-public amongst the 47 of us there are now or something like that, or totally public because it's on YouTube. And last but not least, I, like everybody else who's putting together these meetings, we're learning as we go. So items are subject to change. Any questions? Okay, then one other announcement I wanted to make. We've been doing some things with the Mid-Atlantic Antique Radio Club, Mark. Mark has generously allowed the participants of this meeting to join their meeting tomorrow. It's normally for Mark members only. So in the chat during this meeting, I'll be forwarding the invitation to the Mark meeting at John Bigg's request.
So, Matt?
Yeah.
If we're going to demonstrate a radio and we can't do a band scan, is that what you're saying?
You can do a band scan, just you don't want to be on a station that's playing music for more than, I believe it's 16 seconds.
All right, that's fine. Just wanted to make sure I understood.
And Matt, thank you very much for the presentation. And before we start our first presentation of the day and the main agenda here, I just want to mention that if you do want to do a show and tell, you don't need to have a formal presentation. If you have something you want to talk about or whatever, show it in front of the camera. Just jump right in. You got 1 to 3 minutes to do it. And that comes at the end of the 4 presentations that we're doing today. Also, in the items wanted, items for sale section, if you have some information that you're going to send in the chat window, please put your contact information in there, and also indicate if you don't want that information sent out in the email that comes out after the meeting. In other words, Tom will put for sale information in an email that goes out, and if you don't want yours in there and your contact information in there, you need to indicate so in the chat window when you put it out there. So with that being said, I will kick it off, and we'll go to Bill Cohn on his presentation, Tips and Tricks, Multimeter Use. Bill's been a regular contributor to our meetings in his Tips and Tricks section, and we look forward to it. Bill, let's move here.
Basically, we had a discussion about various things we're doing in these Zoom meetings, and Tom Kleinschmidt has been doing a sequence where he's fixing a Fada radio. And some people had asked about information on how to repair radios. I'm going to go over really something very basic, and many of you on this call probably already know this material, so excuse the fact that this could be very basic, but there are some people on this call who actually might find the information I'm about to impart kind of informative. And this is tied to the fact that the club has also acquired some test equipment in many of the donations we got, and I know, Tom, I assume you're here. We talked about possibly giving that away down the road to somebody who would like to build up their bench to start repairing radios. So I'm going to talk. This is very, very high level, not very deep, and this is fairly simple information on multimeters. So okay, and a couple pictures here, typical night kit multimeters, and just for a historical note, the reason I picked a couple pictures out of a night kit catalog, I worked for Allied Radio when I was a teenager in the 60s. And actually the meter on the top there was their very low cost VOM, a multimeter. And the one on the bottom was the expensive one I couldn't afford. And I'll explain the differences as we go along here. But I just happen to love to show pictures of night kit stuff, since that's kind of near and dear to me, because it's part of my my formative years getting into this hobby. Although the very first, the very second kit that I built was this VTVM. Now, Heathkit made this. The same thing was made by ICO and a number of third-party kit manufacturers, and it was also available as a product from RCA that was already built. Triplet made these products. You could get VTVMs everywhere. They were almost all identical in design. They all had basically a 12AU7 in them and a 6AL5 in them. they all copied each other, so they all basically work the same way. This is a very basic kit. Believe it or not, it was only 25 bucks when it was new back in 1965. Probably at a ham fest, depending what kind of condition it's in, you can probably get it for $5, or if you go onto eBay, somebody's going to want $100 for it. Personally, I don't think it's worth more than about 10 bucks. All right, so what do I want to emphasize here at this particular presentation? I want to talk about the characteristic input impedance of these multimeters. And in the case that we're talking about here, you realize impedance is a measurement of input resistance, both AC and DC, but we're mostly interested here because we're going to be making DC measurements is the DC resistance input of the meter. And so when you're looking at a VOM, like the first two I showed in the first pictures, the input resistance is measured in ohms per volt. Nightkitt and many people made a 1,000 ohm per volt meter. That was a very common low cost meter. The next step up you would get was a 20,000 ohm per volt meter, and I'll explain what that all is. And you can get some that were actually 50,000 ohm per volt, and I think a few were even available as 100,000 ohm per volt. Since essentially the sensitivity of the meter itself was more sensitive. It had finer windings on it, so it was a more sensitive meter, and that's why the input resistance went up. But this is an interesting characteristic here. Notice it's measured as ohms per volt. A VTVM, or in the case of the later ones, which were replaced at 12AU7 with a couple of FETs, became an FET meter, because my second VTVM was actually an ICO TVM, or FETVM. They have a constant input impedance of 11 megohms, and I'll explain that as well. So the VOM input has 1,000 ohms per volt. So that means if you switch to the, and these are arbitrary, these scales are different depending on how the meter was designed. If you picked a 3-volt scale where the full scale was 3 volts, that meant the input resistance of that meter was 3,000 ohms. That's an important piece of information. And at 300-volt scale, it was 300K, 300,000 ohms. A 20,000 ohm per volt meter would have a much higher input resistance. So on a 3-volt scale, we're talking about 60,000 ohms. And a 300-volt scale, we're talking about 6 megohms input. Again, very important when you're making measurements in a radio, especially tube radios, which are generally high impedance devices. A VTVM, no matter if you're on the 3-volt scale or the 300-volt scale, it's always got an 11 megohm input. And it's important to note why it was 11 megohms. If you've ever seen a VTVM, you'll notice there's always a special probe that goes with it, because the input resistance of the circuit at the VTVM itself was typically 10 megohms, and they put a 1 megohm resistor in the probe. That is considered in the input resistance and all of the calibration of the unit. So if you get a VTVM without a probe, which is possible at a hamfest, you need to make a probe with a 1 megohm resistor in the probe. Why would they put a 1 megohm resistor in the probe? Well, by putting a 1 megohm resistor in the probe, the impedance, or the AC impedance of that meter, was a little higher, because the 1 megohm resistor was at the probe tip rather than after all the coaxial cables. So the capacitance of that probe is a little bit higher. This is important when you're probing with your meter in RF circuits. Granted, you get into some high frequency RF circuits, the meter's going to affect things. But probing around in an AM radio, this is not really a giant consideration. But understand that if you get a VTVM without a probe and you use it with just a straight wire input, it's not going to work right without that 1 megohm resistor in the probe tip. Again, most of you out there who are experienced probably already knew this, but I want to make sure that everybody on this call knows this. So now I wanted to point something out here and why this is important. So I grabbed the schematic out of, this is out of Sam's. And let me see if I can kind of point it. Can you see my, my cursor?
Yeah.
Good. All right. So this is a pretty cheap radio. It's only a 4-tube instead of an AA5. It's an AA4. It's missing the IF transistor, tube rather. But basically, and this one's a fairly low impedance one, interestingly enough. You'll notice the resistor on the plate of the 12A T6 is 100K ohms. Some radios have that as high as 470K ohms. So if you're taking a 1,000 ohm per volt meter and you measure that plate voltage, you're going to get a different reading on the plate of that tube than if you measured it with a 20,000 ohm per volt meter. And so these charts down here, these voltage charts, are very specifically noted down here with measurements made are at 20,000 ohm per volt. So they use the 20,000 ohm per volt VOM when they made these voltage measurements. Not everybody had a VTVM. So in theory, with a VTVM, you might get a slightly higher reading here because it's loading this circuit a little less than a 20,000 ohm per volt meter. And if you used a 1,000 ohm per volt meter, the cheaper meter, and you put it here, you will certainly get a lower reading than in this chart than what Howard Sams did at the time. I would take a real guess they used the Simpson 260 when they measured this. Simpson 260, I believe, is a 20,000 ohm per volt meter. There's an equivalent triplet that's just like that. And that's what a lot of people had back. This radio, I think, is out of something about 1950. Yeah, it says 1950 on here. So very, very typical, though. And a shop would have, you know, a triplet or a Simpson 260, and that's where they're making these measurements. So it's most important to note that when you're trying to look at this chart and trying to figure out what these voltages are, that you're measuring it with a 20,000 ohm per volt meter, or today, most of you may be using a digital voltmeter. I didn't put a picture of a digital voltmeter on it, but typically a digital voltmeter that you buy even at Harbor Freight for 10 bucks, or you spend $250 on a Fluke digital voltmeter, they all have approximately a 10 mega ohm input resistance. That's pretty typical. So they react like the old VTVMs do. So measuring with a digital voltmeter, you don't really have too much trouble here. Most of them do not put a 1 mega ohm resistor though in the probe. So if you're working with a couple of test leads and you put your black lead on the B minus here, in this case ground, and you're just clipping on here, the capacitance is a little bit higher, but the measurement should be pretty close to what these charts say. Even though they use the 20,000 ohm per volt meter, the digital voltmeter is probably going to give you the correct reading against all of those, what the charts say here. So I would take a lot of what this chart says with a grain of salt because of one thing. When they made these measurements, they usually spec here, the line voltage had to be 117 volts. So it's important when you're trying to make these measurements and trying to compare them to what Howard Sams said they're supposed to be, make sure that you're using a variac in front of this. And I also recommend you put an isolation transformer on this radio so that you are actually making the measurements with the input voltage that they specified. They specified 117 volts. That's what you need to put in, or these voltage readings are going to be off. Now, in the design criteria of a radio like this, they're really, the spec is pretty wide. These radios will work plus or minus 10% easily, and some will work plus or minus 30, 40% and still play. So it's important to understand what you're really looking at here. But this was the design criteria, or these are the numbers that Howard Sams got on the typical one they were looking at back in 1950. So this gives you a ballpark of what's going on. You can tell if a capacitor like this shorted because the voltages are, if this capacitor here is leaky, you're going to see some sort of DC voltage built up on this grid here. So that's the kind of things you're trying to measure with your voltmeter. In this day and age, I'd recommend anybody fixing radios like this probably ought to own, either a VTVM or transistor VTVM. They're inexpensive. You want to have one of those along with your digital voltmeter, so you have a couple of different things you can check against. That's basically my presentation. I wasn't going to go too deep here because I'm not going to get into fixing things. I see Rudy is clapping his hands. I didn't want to go into too much detail, but if there's any questions, I'm open.
Well, I would comment that you find out that in the rider schematics of the 30s, that every once in a while you'll figure that, oh, they were really making their voltage measurements based on 1,000 ohm per volt.
I would agree with you, Robert. You're right. Back in the 30s, because making a meter that was with that fine wire, it was a design criteria that came a little later. I'm sure thanks to developments during World War II, and as we were moving heavy duty. Right in the early 30s, the meters were basically 1 milliamp meters, and they built that VOM on. I see you nodding your heads. I guess you're agreeing with me.
Right.
That was probably the criteria at the time. And you're right. You're absolutely right. You can use 1,000 ohm per voltmeter, but understand what's going to happen when you start probing in the radio. You're going to get the meter itself is going to affect the readings because it acts like a resistor that you've added to the circuit that wasn't there when you take the meter off. And anybody who's done any radio repair work, always early on, you get amazed when you stick your meter in and it works, and you pull your meter off and it doesn't work because some resistor was open and all of a sudden your meter became the resistor. So that's another little surfacing tip you learn as you get more experience, I think, here.
I have a question.
Sure. Go ahead.
Oops, sorry. I'm just starting into trying to get radios to work. And is there on the resistance meter selection on a Simpson 260? Is there voltage on the probes?
Yes.
So you can blow. I wondering how I ruined all my 1 volt tubes in a Philco portable radio by just checking continuity of the filaments. So is there enough low voltage there to blow a 1 volt filament in a tube?
It really shouldn't. Correct me if I'm wrong. I don't have a Simpson 260. Typically, they only had is it 1 C cell, or do they have 2 C cells in there for 3 volts? But I think it's 1.
1.
It would be the same as the voltage as that tube. I've measured those tubes before and not had that problem. You're looking like a 1U4 or a 1R5, something like that. You should be able to measure with a Simpson 260. But I defer to the group here if anybody has more experience with a Simpson 260.
I had a 260, and basically they have 2
It's
tri-cells in there, 1 volt, 1.5 volt, and a higher 9 volt or a 12 volt. And if you have it on the 12 volt and you check the small tubes, the 1 volt tubes, it'll blow them up.
Okay. I defer to you, Ed. I've not used Simpson 260 for that.
Well, thank you very much.
That's why we have a group here.
Awesome. Great questions. Well, thank you very much, Bill, for that excellent presentation and the excellent questions and information in the chat window that Robert put in there. So it's a great exchange and some good tribal knowledge there about using a Simpson 260. So there's a good reason to get a DVM when you're checking your 1 volt. So with that presentation behind us, I'll thank Bill again, and we'll move on to our second presentation of the day, which is going to be from Larry Snyder of the Colorado Radio Club on his restoration of a Zenith radio. So Larry, are you ready to go?
I am.
Take it away.
Take it away, huh?
Share your screen.
Okay, this is a 1938 Zenith 6S229. I titled this presentation, "The Radio Left Behind." I'm going to read this to you. Originally, this was recorded with music. So we'll go ahead with this. Long ago in the land of radio, there was a band of Zeniths. They were adorned with illuminated black dial, large black dial at the center, and encased with a black brass ring, 4 knobs across the bottom, and a large speaker above. When the 4 knobs were turned just right, good old music would come out the speaker above. Sadly, this radio's prominence in the land faded, and ravaged by time and a brutal gang of elements. One of these tombstone radios became unappealing and was discarded. Decades later, it was rescued from an aircraft salvage yard, which was located near the old Denver Stapleton Airport. It was rescued by a fellow CRC collector, and I acquired it at a raffle on March 15th for $1. This is photos of that aircraft salvage yard. The photos are courtesy of a Denver radio station, KDVR, Fox 31 TV News. It just shows on the left here, their photo of the salvage yard closing. And on the right is an aerial view of the aircraft salvage yard. This yard had a, well, it was sold to Acme Aircraft Sales. And they were having this big sale to get rid of everything because this land was going to become a new shopping mall when the Stapleton Airport got moved to become Denver International Airport. The advertisement on the right came from a 1937 magazine, the fall of that year. The radio has 6 tubes. It has American and foreign broadcast bands, a police band, 6-inch speaker, station relocators, and it covered the normal AM bands and high frequency bands. At that time, in 1938, these on the left, this presentation was supposed to have these tunes playing in the background, but sadly the copyrights on music material, I believe, is 95 years if the persons receiving money from that effort is still alive. So at that time, we could hear Bessie Smith or Billie Holiday, Duke Ellington, Count Basie, or Benny Goodman. This was the radio as I got it. It had this artificial wood-grained, I call it a decal, on the surface, and it didn't survive the weather too well. The 4 knobs across the bottom were missing. The brass ring was corroded. Getting some other views of the radio. This on the right, this is the bottom chassis board. It was plywood. It was coming apart. It was all delaminated. In the photo on the left, the chassis board has delaminations. It's out of its groove on the side wall of the radio here. And there was something growing out from underneath the inside. And we can see some of the deteriorated wiring. These are other views. On the left, the radio was basically covered in a mud or a silt, like it had been either in a flood or wind-blown dust and moisture got into it. We can still see the delaminations down in this corner. And this side of the radio is warped out, visibly warped out. Okay, the chassis was covered with the dry silt that I mentioned, and the inside had been home to spiders and wasps. Actually, there was a live spider in there when I got to working on it. We can see how the dust and the dirt was inside the lens here. So the cabinet restoration, it needed a new chassis board and a new bottom trim piece. There was a piece missing. It needed the straightening of the sides. It had to remove the original wood grain film. repair and restore the top veneer, which was also loose, and staining and shellacking it. The radio required a new supporting trim, and this is the new trim here on the right. This piece was missing in its entirety. And I made a new chassis board. The chassis board fit into the sides of the cabinet. I needed new brackets and braces here, new brackets in the corners to hold this sideboard in place. On the left, there are other views of these corner braces. This is about a 2.5-inch diameter radius in these corners that I had to make the braces for. There's the new trim piece and the new chassis board up here. So getting on to the refinishing, when I started removing the old skin decal, it came with this nice appearing grain wood that I thought was pretty neat. So I decided I'd take all this off and refinish refinish the bare wood. So first I had to use my clamps and straighten out the sides. Had to re-glue the laminated top. Clamps here holding the top down. And I repainted the insides the original royal blue. I read somewhere on the internet that Zenith used royal blue on the inside of their cabinets. These are more pictures of clamping down the delaminated top and applying the oak veneer. This photo still has my clamps pulling the sides together. So the cabinet refinishing included Minwax pre-stained wood conditioner to even out the stain, 2 coats of Rust-Oleum wheat stain, 4 coats of Zinsser amber shellac, which gave it a real nice dark tone. And I used a sanding sealer and glossy black paint to do the bottom trim, which was particle board, and to paint all the surfaces around the speaker cutouts. Then I had to move on to the chassis restoration. It needed a new power cord, a new tuner drive belt with tension springs, a new tuning capacitor, a tuning capacitor disassembly and cleaning. It needed, of course, new resistors and capacitors, new rubber grommets under the tuning condenser, reproduction Zenith knobs. I completely stripped the metal chassis and painted the chassis with copper paint. And I repainted the dial lamp housings. We'll get to that in a minute. So this photo on the right shows all the restored capacitors and resistors. I put these little white number tags on everything so I can find it later. Like this is resistor 2 or something. And this was the original setup with all the parts. When I was looking at this yesterday, I was wondering what the hell was this up here and this over here. There's an opening in the chassis, and this is looking through the chassis to my background whatever is behind in this photograph. Like this is probably a schematic, or this is background in my workshop. So the radio only needed 2 new tubes. The other ones were workable. This photo on my left, I have repainted the metal chassis, except I did not paint the area where the model number, Zenith model number, was painted on the chassis. This photo on the right shows the dirty housing here. This black dial was warped from the heat. I had to put that dial between 2 towels, moist towels, and I actually ironed it flat. With the heat, I got it to become flat again. And the new Zenith knobs are shown here. The dial lamp housing was repainted. This was all black and dark. And these lampshades were scorched, cracked, and deformed. The light bulbs are behind these 2 shades. I installed lower wattage light bulbs to prevent the heat from scorching, and the ventilation of the housing was enhanced, so the dial distortion caused by trapped heat was reduced. What I did was, up on this surface here, I drilled 2 1/4-inch holes to let the heat out, and down in the bottom I put some holes to let cool air come in and circulate behind the dial. Tuning condensers gave me fits when I was trying to get the radio to work, and I finally pulled it out and had to clean it. Back where this spring loads the shaft, this was heavily corroded. I had to clean that up. The bearings were like the grease had solidified. So it was just very, very dirt. Oh, I had dirt and rust particles in between the plates. So I took that all apart and cleaned it. It was a 0 to 470, well, actually about 20 to 470 microfarads. So this is it restored. And before, it looked like this. This is a before and after. Again, I painted the trim piece black, and underneath the bottom of the base was black. I did nothing to the speaker. The speaker was originally this copper plated, or I don't know if it was plated or painted, but I did nothing to the speaker. The speaker was great. I replaced the speaker cloth. And I'm pleased to report that the operation was a success. The 83-year-old radio has fully recovered. Its original beauty shines again to pull great oldies out of thin air. The cabinet underwent treatment for long-term exposure. This near-fatal condition required replacement of the chassis board due to severe lamination, repair of broken limbs and missing internal braces, straightening of deformed and warped sides, replacement of the bottom missing molding, a cosmetic makeover was necessary because the original screen had a wood grain decal that was regrettably not surviving the repeated exposure to the elements of weather. The chassis went into surgery to remedy many inherent geriatric disorders. All not up to snuff internal bits and pieces were replaced with modern implants. The original vein-like wires were hard, brittle, corroded, and, as expected, replaced. The insides of all the metal cans were fully examined, and the prognosis is excellent. The internal vital organs like the power transformer and speaker coils were also healthy and found to be fit for service. And the missing knobs on the front digital extremities were replaced with prosthetic devices.
Well, Dr. Larry, you did a great job.
Well, thank you.
I must say, Dr. Larry,
That is beautiful work.
that's
Yeah,
pretty cool.
We have a list of suppliers and where I got all my parts from. And in closing, from a hobbyist viewpoint, the neat thing about working on basket case radios is knowing you cannot make them any worse. And there is a lot of personal gratification when they are restored to original functionality and appearance. I encourage you all to never pass up acquiring unsightly abandoned radios. It is our responsibility to protect and preserve these radios where we can, not only for us, but for future generations of collectors. Thank you.
Good job.
Yes, sir. I've
That is
owned two.
just beautiful work.
I've owned two of those radios, but none of those compared to that, though. Matter of fact, I still have a case. I still have a casing for one that's in almost as good a condition if anybody wants one. So, but I'm not going to overstep it. But good job, Larry.
Well, thank you much.
Love those Zeniths.
Say, Larry, I got a question for you. This is Rudy.
Yeah, Rudy.
How did you straighten out the warp sides?
Just by gluing and clamping it to the new base. I'm not the glue and some brads hold it in place.
Okay, so that
I just
straightened
pulled it together, glued it, and nailed it.
Oh, okay. So that straightened the warp then, huh?
Yeah.
Wow, that's good.
Hey, Larry, I have a question. I'm trying to get an old Teletone radio in about that same condition to work, and it looks like it was buried at one time. So what chemical did you use to clean the tuning capacitor and that chassis? Because mine has some kind of a deposit on the chassis, and I just what you used to clean those.
Yeah, what I used was electric contact cleaners,
Okay.
like brake fluid, things like that.
Okay.
But a lot of these old radios, especially if they're battery radios, get corrosion from the gas coming out of the lead acid batteries.
Oh,
And that requires something a little stronger, like wire brushing and steel wool to get the corrosion off the copper.
okay. So how far did you break down that tuning capacitor? Did you take the individual plates out to clean them, or how did you totally disassemble that?
Yes, I had the original. I had the loose plates, and you know, on some of those old capacitors, they put this zinc pot metal between the plates.
Yeah.
And not on this one, but on others, that the pot metal distorted the plates, and I had to replace them with commercially steel washers.
Oh, really?
Yeah.
Okay. I don't think mine is quite that bad.
But this one didn't need that. The plates were still parallel.
Oh, okay. Yeah, my plates are parallel. They're just scummy.
Scummy.
Yeah. Thank you.
All right. Any other questions for Larry?
Oh, well, that was a great presentation, Larry. I actually just restored one of these myself last month. I found one on Facebook Marketplace, and it Wasn't quite as bad as yours was, but the photo finish was totally sanded off on mine, and it was just a bare plywood finish. I couldn't really do anything with it. So I was poking around on Amazon, and I found this stuff. It's vinyl adhesive backed wrap. It's basically used for car dashboards and car trim inside. And I found a roll big enough for it, so I thought, well, let's see how it looks. So this is how the radio looked when I got it. You guys can see that.
Oh, yeah.
And after I put the wrap on, this is how it looks now. Let's see if I can get it in the camera here.
Oh, so you had to do all that cutout to get around the speaker opening, huh?
Right, right.
Yeah.
But mine didn't have the nice grain. Didn't have the nice grain finish like yours did. Mine just looked like plywood. So this actually enhanced it more than what it would have been.
The top of that radio, my radio, I used that sticky back on the top of your veneer.
Okay.
It comes on a roll, right?
A lot of these radios didn't have a laminate on there. What they had is a 64th inch of basically walnut formica. So it wasn't a laminate. And that's why so many of them survived. And when you put stain on them, they come back to life.
Yeah, so mine must have had that laminate because I had a beautiful grain underneath it. Yeah.
I knew a guy that worked for Zenith, and he says basically that's what they did is they used plywood underneath and they used the laminate on the top between about 1930 to about World War II.
Well, somebody took a power sander to this one because they actually sanded off the groove.
Oh yeah, it's gone.
Yeah, so it was basically down to the plywood, so I had no choice but to try and find something that would make it look like grain again.
Did you get your radio to work?
I did, yeah. In fact, I just finished it up about a week ago. I found it on Facebook Marketplace right here in town, like about 10-minute drive from my house.
That's great. Well, that was a great presentation, Larry, and some great questions. And it's great to see that other people have that exact radio. That's very cool. And, you know, when we finally get around the for sales, you know, maybe there'll be some more radios for sale like that in the for sale section of this meeting today. But for sure, the club has got lots of donation auction items that are considered basket cases. So if you want to be inspired by Larry, the club will have a radio for you, I'm sure. So
yeah, my hobby in collecting radios is to collect and fix basket cases. And once I get them restored, I put them on the shelf and I basically forget about them. The thrill of the chase is gone.
Well, we're going to have to call you Dr. Larry Snyder from now on because you brought that one back from the dead. So
thank you.
So,
Hey,
right,
Larry,
so
I got one more thing. I said, I like the way you explained everything in geriatric ailments.
we can all identify with that. Yes.
Well, yeah, I got to have a little humor in there somewhere.
All right.
That's cool.
So, so let's move on to the next presentation, which is a regular occurring part of our meetings, and it's part 4 of the radio preservation series that Tom Kleinschmidt's been doing. This one is called Fixing the Fada. So, Tom, if you're ready to go.
All right, well, I guess we'll get started. We're obviously going to start seeing if we can get the white smoke to pour out of this thing. But before we do that, again, as a reminder, and for those who haven't been part of the series all along, this is the radio as I picked it up. And it's a 1947 model as far as I can tell. However, the schematic I'm going to show you later is from 1941. And just a trivia fact is the schematic doesn't have the tone control on it. So my guess is they evolved the design. So this center thing here is a tone control. So tuning, tone, on, off, volume. One more cabinet thing. You may recall there was a large kind of crescent-shaped crack on the side, and I was a little concerned about that becoming a bigger crescent-shaped crack and maybe even becoming a piece that fell off. So I just put super glue over the edge of it. I didn't try and get it inside. I'm sure some capillary action got it inside, but I didn't want it to appear on the outside of the cabinet. And that did the trick to keep those two pieces from moving relative to each other. So the crack is still there. The crack is still the crack, but that's the only one that I could tell was done by some kind of shock damage. Everything else was done by pressures of screws or stress in the plastics when we went through that the last time. So if you didn't see that, you can go onto our YouTube channel and see about all the little cracks and defects. This was a crummy molded case, to be honest. I mean, it's not awful, but it's definitely a 10-footer. So tweaking the approach thing here a little bit. We're obviously talking about test and repair now versus cleaning up a cabinet. And I'm not telling you it's the right way or the wrong way. I'm telling you it's just a way. And just like many of us, I'm trying to make sure that people that haven't done this before have some idea what's going on. So a little bit, this is going to be 101, and a little bit of it may be something you can pick up on your own. So here's where this is our sequence of events. So we're going to do this first chunk, take a look at it, test it out, and do some basic repairs before we do any serious part swapping. So, part of the thing you have to deal with, as Larry pointed out, that cord was pretty awful on his set, and most of these sets have rubber cords that disintegrate. And if you go earlier, they got fabric cords that disintegrate. So the odds of you having an original cord that's in good condition, even if it looks good, it probably isn't. And so we'll talk about that in a bit, and then all the other parts. So here we go. As you may recall in the first photograph, this yellow electrolytic capacitor was just kind of hanging out in free space. And it likely was the original capacitor that was on the chassis, and it got replaced by these two gray guys. And I don't know why the person that replaced the two gray ones didn't just cut it out completely, because I'll call it the hot side, if you will. The two elements are disconnected, just the ground is still hooked to the chassis. So, a snip of a wire cutter, it's gone. But looking at the rest of the chassis, it looks pretty well untouched. In fact, Larry, it's probably deja vu of the chassis you looked at on your Zenith from that viewpoint. So then we go to the top. It's a little dirty, not awful. All the insulation, again, you're dealing with a lot of cloth wire here. If you're in a really hot environment, this cloth wire can turn to dust. This is all very pliable. It's all in good shape. Everything seems to be fine. There's nothing broken, nothing missing that's apparent. And then we go to the front. The speaker had a million holes and cuts and stuff in it, and I didn't go through to show you how to do it, but you all know how to use contact cement, and I just fixed it with contact cement. The important thing with a speaker is you don't want loose pieces of paper flapping around. It'll buzz at certain frequencies and it'll continue to tear. And then the other thing you do is very carefully with your fingers, kind of right about where this little ring is in the paper, you just push it down and back with your fingers to make sure it moves within the magnet structure and doesn't make a kind of noise like it's dragging. This one doesn't, it's fine. And that's sort of the front of the radio. So then, next step, power cord. This card's been replaced. That's the good news. The bad news is it's got a cut in it. Something landed on it along the way. I don't show you the cut, but it's just a razor thick cut, and I'll be replacing the cord because of that, because it's halfway down the cord. Also, the important thing is right here where this red arrow is that this grommet is missing. Again, probably rotted off, but that's a sharp edge on that metal. So eventually that will cut through the cord. And of course, if you like fireworks in your kitchen, I'd leave it like that. Otherwise, we'll put one of those on there eventually. But for purposes of what we're doing today, it's not abraded, and I'm not going to do anything with it. So keep in mind, we're in a preliminary test mode. We're not in a deliver it to the customer mode here. All right, so next step, initial test and repair. I have had a rash of bad on and off switches lately, and this one's no different. The other two were completely not working. They just wouldn't turn on. This one had almost 70 ohms of resistance. And I will tell you, I fired up the radio, which is actually tomorrow's thing, and with that 70 ohms of resistance, or next month, it won't work. So I flipped the switch on and off a bunch of times and did all the usual incantations, but it wouldn't work. And this is a very tight fit in here. In fact, there's actually a paper gasket underneath here. So just shooting contact cleaner in there wasn't going to work. So we got into major surgery. So I disconnected the switch wires. You might have noticed it's got this kind of paper part number thing on the back, which is something I've seen before, but not very often. And I was able to swing the control out of the chassis and leave all the volume control connections there. And because I didn't want to take the whole world apart if I didn't have to. So quick tip, make sure you photograph it or make a diagram or put tape on the wires or do whatever you got to do. Because if you get delayed a week and have to put this back together, it becomes a detective story. Or if you're over 60, it's a detective story 10 minutes after you undo it. So that's a real important thing to do. And you have to be careful when you twist this stuff, you don't break a component. The other thing is I'm going to use a bunch of terminology interchangeable, whether this is a variable resistor, a control, a potentiometer, or a rheostat. For our purposes, it's all the same stuff. So next step is these 3 tabs have to be bent over, or up, I should say, and then straightened out with your long nose pliers. And this is just a pocket knife to get underneath there. They're very tight. They were put together in a fixture originally that really crimped them very well. And then it's kind of a little bit of a fiddly job here to jiggle the switch and pull it off the back of the pot. Now, I will make a note of this later, but you don't want to turn the pot, okay? You need to leave the shaft where the shaft was. So sometimes when you get them realigned, you end up, or not realigning them, and the pin that's on the back that switches the switch gets jammed up in there. So here's the switch inside. So we flip the switch over, those 2 contacts you saw on the back side. The good news is this little phenolic piece is in really good shape. Nothing's corroded. This is the switch contact here. This is one side. That's the other side right there, that little pin. And I was able to flip this little guy with the 2 little ears on it back and forth. And you can see the spring flops as a toggle and then flops this thing back and forth. This would be a lot more fun as a video, but I didn't take a video. I apologize. And that all worked fine. And I got out, I think, most people's favorite contact cleaner, Deoxit, shot a little on there. And ta-da! We went from 70 ohms to 0.4 of an ohm. And I manually toggled it back and forth a bunch of times on my bench to make sure it wasn't some kind of an anomaly. And by the way, when you're testing a switch, Bill Cohn, it doesn't make any difference how many ohms per volt it is. So then now it's back to putting it together. So the switch was in the on position when I took it off. You have to make sure it's in the on position when you put it back on. If it was in the off position, same thing. And again, don't turn this shaft. So you slide it back on. Again, it's a little fiddly and wiggly. And then I bent the tabs over this time with a pair of regular slip joint pliers, and it just pushes them over beautifully. And so then the other thing for people that aren't real familiar with potentiometers and switches, they most of the time have this little tab. It looks like a screwdriver slot in here, but it's actually a little tab of metal off the other side of here. It'll be off of this corner over on the other side. And that has to be in this hole. And it's important to be in that hole so the pot doesn't turn when you try and turn the volume control, especially in the on-off position. It's going to want to rotate the pot and rip all the wires off. So it's not hard to do. It's an alignment thing. You slide it in and spin the nut and the washer back on that were on there before, and it's back together. So schematic wise, what we're looking at is here's the on-off switch down here. Here's the volume control up here, this 500 mega ohm volume control. Now they didn't show it as a dotted line, but that's what it is. And that's an important thing when you're looking at any schematics. Dotted lines mean that something's mechanically tied together. So you look at the tuning capacitor. In fact, that one that Larry showed is a perfect example. You've got 2 tuning capacitors on a common shaft. That's why they've got this dotted line shown here on this rider schematic. And I don't know if it's a rider's, but it's of that genre. It's actually off the most often needed. I don't know where it came from, maybe from the manufacturer. But when you go into riders, this is basically all you get. When you go into Howard Sam's, you get a really nice portfolio of information. So pre-war radios is a little more detective work generally than post-war radios when it comes to the servicing data. So that's what we fixed. And again, to reinforce what Bill mentioned or somebody mentioned, I think in a previous meeting, you're always switching ground on these hot chassis radios to keep the AC noise under control. It's counterintuitive because you normally are switching the hot. If you've ever done any wiring in your house, you're not switching the neutral wire, you're switching the hot wire. But on a radio, you are always switching the ground so that you don't get 60 cycle hum running around inside the set because it's the same potential as the chassis. And usually the switch is way across the other end of the chassis from where the power cord is. So that is where we're at right now. And next time we're going to fire this guy up. What do we got for questions?
Sometimes, Tom, I use this liquid tape. It doesn't show anything. I got it from Antique Electronic Supply. It works good for the speaker.
Oh, yeah. And I've also had to glue paper onto the speakers when I've had a hole big enough to get them repaired too. And
What kind of paper? What kind of paper do you use for that?
I'm sorry?
What kind of paper do you use for if it's missing a section of paper on the speaker?
You know, when you get something from Amazon and it's got that wad of brown paper in the box, I've used that.
Oh,
You know, we're not fixing high fidelity speakers here. We're fixing speakers that are playing AM radio. So, I mean, as long as it's not rasping around, it's going to work.
right.
I'm sure there's proper paper you can buy to repair cones, or just get a replacement cone and cut a piece out of it and glue it on. But I took the frugal method and just found something that looked okay. I've also spray painted the whole cone again after I fixed it. If it kind of reflects through the growth cloth, to make sure you don't have these splotches behind the growth cloth.
I've heard that you can also make a slurry out of like toilet paper and Elmer's glue, and just kind of put that into the hole or wherever there's a bad part.
And you know, the other fun fact is people that used to scratch build models for their model railroads used to make the roofing material look correct for early passenger cars by taking toilet paper and doing the same thing, but using it more in a sheet than in a wad. So yeah, the only thing is structurally toilet paper is not really fabulous stuff. So the glue is it's kind of you're almost making like a fiberglass. You know, you've got the fibers of the paper, and you got the glue to make an agent that'll hold it together. So yeah, there's lots of ways to do it. I just happen to have a bottle of contact cement always handy, and that seems to do the trick.
Rudy, tell me again what that company was that has the liquid tape. Antique what?
No, I got it from Antique Electronic Supply, but I think you can get it online anywhere. It's just called it's GB.
Hey, Rudy, why don't you put that in the chat window for us? That'll
Okay.
save some time.
Yeah, that's great. We don't need. Yeah, I don't need it right this second. I'll check the chat box.
I'll do that.
Okay, thanks.
Yeah.
Any other questions for Tom? Well, if not, we'll thank Tom for that great presentation, and we anxiously await the next installment.
One other thing, when you're talking about the power switch and one side of the line cord goes to ground, the old chassis did not have polarized plugs. So half the time the chassis was hot when it was turned off, the other time it was hot when it was turned on. And I had a customer said, I didn't even turn it on. And he says, I woke up an hour later because he had a pacemaker. And I says, you got to use an isolation transformer. So yeah, the AC DC radios, the chassis is always hot, either if it's on or off. And when I replace it with new power cords, I use the polarized power cord.
There's some good advice there. So, okay, any other questions for Tom? If not, the next presentation is by me. So I will show you what I'm going to present, and then I'll go into the presentation. But I built a radio cradle, and if some of you have had the chance to read the ARCI newsletter from the month of February, I wrote an article about this, but if you've seen that article, then this might be a little bit old hat. But what I'll do is I'll go through my presentation here. And the first thing I can say about a radio cradle, first of all, you guys able to see that?
Yes.
Good, good. first thing I'll say about a radio cradle is it's really something that I didn't really think would be that great of an addition to my workbench, but it really helps a lot. And I think the main thing, it just speeds things up and you don't have to worry about breaking stuff, because you'll end up spending a lot of time if you do break something on your radio. Like if you tip it over and you crack a coil, or you break a bracket or something, it's a great addition. But you can see the dimensions of what I built here. It's I built it wide enough to hold this one particular Zenith chair side I was working on, and I figured most of the radios I work on are that size or a little smaller. And as you'll see later, the way this comes apart, if I want to make it wider, I can just take it apart and put in longer extrusions. But what it's made out of these aluminum extrusions that are normally used by woodworkers to make jigs and things like that. And they're called T-bolt extrusions. And there's 2 pieces of plywood and a bunch of mending plates and wing nuts and brackets. And that's basically the parts list. If you look at the article in the ARCI, you can see more detail on how to get a hold of those parts. And all of these rails are adjustable. You just loosen the wing nuts and the whole thing can be adjustable, so you can mount just about any size radio that'll fit between those 2 pieces of plywood. And so here's a picture of it with a smaller radio that only has 3 mounting holes. And then the key thing here is you're just using the radio's mounting screws that it mounts to its case or cabinet, and you're hooking those screws through these mending plates, which are on these adjustable, slidable T-bolts. And that's a close-up of what these extrusions look like. And the way this thing's built with the slanted cut on the plywood is it allows you to flip this thing over and get 2 different orientations. And if you have a very tall chassis, you'd use the approach on the left, and that keeps the chassis up in the air above your bench. And if you flip it over and around, you can use it for short chassis, and it gets the chassis a little bit closer to the surface of the bench. And if when you're working on it, you rest your arms, it might be a little easier for you to work on a smaller chassis that way. But the fact that it's you can put in very tall chassis is a very useful thing. Here you can see this chair side I was talking about, and at the top of the tuning dial there's this push button tuning assembly that's got all these push button shafts, and it's a very flimsy metal thing that if you were to let this chassis roll over on it, you'd probably bend the mounting brackets for this thing. So this chassis is held up above the bench, and you don't have to worry about bending this thing. So that's a very good, and you can see that if I had a taller chassis, I could just slide these T-bolts up further, and I could get this thing even higher up off the bench top. And so here's a picture of just the fact that the surfaces of the cradle are flat. You can flip this thing all around. And so there's a picture on the left where we'd be working on the inside of the chassis, replacing parts. And then here's it where you flipped it over and you're working on something on the top of the chassis. So you can have it hold your radio while you're doing all kinds of different things to it. And here's a picture of how the sides come off. And you just loosen these wing nuts, and then you just slide the side off. And so if I had a really wide radio, like an old gasket style radio, I could go buy some longer extrusions and make this thing wider if I needed to. And then there's kind of well, these are kind of the pieces that you need to go make one of these. So I built this thing last fall after I restored a bunch of cabinets, and before I decided to go and restore the chassis, I got real ambitious and I decided to build this thing. So if you want to know more about it, you can read the February ARCI newsletter for details, and there's some links in there to these where you can buy these extrusions and stuff. So That's my presentation. You got any questions?
Did you make a schematic for it or a diagram?
I did not. If you look at this picture here, you know, that's about all you need to know. If you took a piece of plywood and you cut it 12 by 16 by 6, that's pretty much it. And then you can mount these things anywhere you want. It's not critical where you mount these things, because the fact that everything's adjustable, you just got to get some brackets and mount these things to the plywood. And the article showed you some close-ups. So if you're inspired to build one, you could probably do some reverse engineering and make your own drawings. But no, I did not make a mechanical drawing of that.
Very good job.
Thank you.
There is a guy who's making wood ones of these that have been available for sale, and I was just trying to look up to find his name again, and I can't find it. But if you look on the Antique Radio Forum, there's been discussions on it. And
yeah, I did reference that guy's website in the article.
Okay.
At the end of my article. So if you want to just go buy one of these things that's made out of wood, maybe not as featured as this thing, but
and he has two sizes for the small and larger chassis.
yeah, that's correct.
I was lazy. I bought them.
Okay. So that's my project that I worked on this past fall.
Looks very good, Tom.
All right. Oh, and Larry's making a comment there. I should thank Larry for inspiring me to do this, because as I said in the article, Larry had written an article for the Colorado newsletter describing a cradle that he had built. And so I used that as kind of my launching pad, and went off and did this one based on Larry's article. So thank you, Larry, for publishing the article.
Tom, your device has a lot of great features, and it's a big improvement over mine.
Well, thanks, Larry. Appreciate that.
Hello, this is Keith. I got a quick question. On those T-bolts that actually fit into those slots, it's made where you can drop the T-bolt down into the slot and then twist it where it slides. Yeah, I believe that's what it is. So you don't have to take your side panel off if you need to add a T-bolt or two. Correct?
Well, yeah, it depends on which. Yeah, no, you do need to take the side panel off to get the T-bolts in there, because the plywood's in the way. But it's pretty easy to take the sides off. And what I did is, you can see here, I got like 4 T-bolts in each rail there. So I just leave them in there, and that gives me plenty of flexibility to do that.
Or you could leave just the T-nuts as spares in there in case you think you might be adding something later.
Yeah, but yeah, and it's not a big deal to take the side off. It really isn't. So.
Okay. Thank you.
Yeah. Okay, well, you see some poll questions there. We've reached the end of our main presentation section of the meeting today. So we are now going to go into the show and tell section. And I do believe we have a few show and tells. I have a show and tell, which I'll bring up later. But after we do the show and tells, then we're going to go into the items wanted, items for sale. And then after that, we'll go into an open session. So with that being said, what I'm going to do is turn it over to whoever wants to do a show and tell first.
Well, I have a little something here that, let's see if I can show this. I don't know if you can see this. This is from a car radio. This is Atwater Kent. Has to be 1936 or before. I mounted on a little wooden block. But they had little cables that ran out the back here, went down to the box under the dashboard of the car. And it's just kind of neat. The tuning still works. And it's a nice little display piece, I thought. Restored it, put a new glass in it.
Greg, if you turn that around, yeah, I think that's the style that they would have had a clamp that went around the steering column, and it would have been off to one side.
Yeah.
Oh, that's a good picture.
Yeah, and that's strictly aftermarket stuff. None of the car companies ever sold them with a clamp to the steering column. Style. They would put that control head in the dashboard with a different fascia around it if it was built into the factory as an option.
Yeah, I thought some of the very early ones might have been mounted on the steering column, but
well, they were always in luxury cars like Packards and Cadillacs, and they built them into the dash. Same style looking thing. It's just matches all the rest of the gauges, and it's just in the middle of the dash.
right. Oh, yeah,
I
guess
might
that was
mention that Ron Frisbee, who was a well-known antique wireless collector in Pennsylvania, had came across one of those Atwater Kent radios, and he claims that he used that as a justification for buying a Model A Ford, so he could put the radio in it.
anyhow, that's my little presentation.
I have something. And though it's not as nice as Tom's, I also picked up a stand if you want to get one commercially, as opposed to building your own if you're not that handy. I don't know, can you see this in the image?
Back up a little bit, Terry. Very good.
How's that?
Perfect.
And it's not bad if you're not handy. It is fairly sturdy. And you can see in the front, there's a cradle, so you can rest the chassis here in the cradle. Then you have adjustment along the bottom of it. It's fairly wide. It's a little bit wider than I want for my taste for hi-fi gear. That's what I work on. It's mainly designed for guitar amplifiers, which some of the chassis on a guitar amplifier can be fairly wide. So not bad.
Looks like you've completed your CAT scan.
What's that?
Looks like you've completed your CAT scan.
Yes, yes, she helps me. She's my girl. She helps me with this.
In the 1950s, they used to sell stands for working on record changers. And most of them were flimsy. They had two mounts, but for the small AC DC radio chassis, they were great. And they were only about $5.95, and they adjusted forever, but you couldn't put the Beekers in the chassis on it. It would collapse them.
I've got a little show and tell. So I thought I would share my tiny portable RCA BP10. So this guy was the first commercial radio to use the new a la 1940 1.4 volt tubes, which makes it much smaller than all the previous portables at the time, and was quite a good performer. Uses your typical superhet design. Obviously, there's no rectifier, but you'll see that it's got the 1 volt tubes, and it heats up the filaments really fast. One of the things that impressed me about it. I think it's a nice looking radio. I was fortunate that the one I got actually included a leather case that was still in good condition. It just needs to clean up and wax. It required your typical restoration. Fortunately, the coils were okay, which is a godsend because this thing is so small that it's a real difficult radio to work on. But it had your usual dirty switches and pots, required a recap and replacing a bunch of wire. Nothing particularly unusual about our dead wax caps. I did find that there was a penny stuck in the radio underneath the A battery to prop it up and keep it solid. I don't know if you can make it out, but take a look at the date on that penny from 1941, which I just thought was terrific that nobody had moved that battery since 1941.
That's the $10,000 penny, isn't it?
Let me know if it is later. But what about that other battery? You can't buy these 67.5 volt batteries. And I really wanted this thing to work. I had thought about using a higher current, lower voltage combo, like a couple of D cells and a boost converter. But the boost converters are electrically very noisy, and putting that inside of a radio receiver did not seem like a good idea. So I decided just to keep it simple and use the stack of 7 9-volts. To make it look like the battery, I found the artwork for the battery on the internet and glued it up to a piece of cardboard from a cereal box, cut it out accurately to that shape, and then used a whole mess of 9-volt battery connectors, perf board and fuse. And you can't really see it here, but I had to pull the other end of that battery connector, the piece that goes over here, out of a dead radio. And that was the plan. Unfortunately, when I put it all together, the 7th battery didn't quite fit inside the box. And so I had to take it down to 6, which meant I had to take it all apart. Unfortunately, put tape over the whole thing, and that's why it's all shiny now. Not the way I want it. But 54 volts works as well.
Using specific frequencies on radios that can use hundreds of them, making it difficult for outsiders to eavesdrop. But a federal judge accused prosecutors of backtracking on claims that one of the 4 directed a strategic plan to breach the Capitol.
6'9", 275-pound sophomore from Rock Hill, South Carolina. That's where Winthrop is located. He started his collegiate career in Tennessee and then transferred. Second free throw is...
Did you notice how quickly it started when I opened it up? It's almost like solid state. Anyway, when I was researching this thing, I was surprised to learn that they were actually issued to the French resistance. In 1943, 150 of these units were delivered in France during a clandestine landing operation. There's a link on there to find out more. But that's all there is.
I have a comment.
Sure.
The battery, that's the 67.5 volt battery, RCA contracted with Eveready to take their original Minimax battery construction technique and adapt it to power the radio. And that was a nice, timely sort of technological development, the battery, because that wound up being the ideal battery technology to use in the World War II handy talkies that they made by several 100,000 of them. And called the Min-Max.
So did the same 67.5 volt battery?
Well, no, the cell itself, if you take that apart, there are 2 stacks of cells in there, or I forget, maybe 3 stacks of cells. But the one that's used in the, what is it, BA38 battery, there's a single stack, a long single stack. And, but it was, the good thing was that when the military needed when Motorola needed a suitable battery, Eveready was ready to go with that technology.
Yeah,
Don't they make a 22.5 volt battery about the size of a 9 volt?
Well, there used to be one called a photo flash battery, and and they may still be available under Varta, but they're so expensive you don't want to use them.
Rudy, they are. In fact, I was on the Texas club meeting a couple weeks back, and people were talking about them for use inside VOMs because they are used in some meters for the high resistance ranges. and they are still available.
But they are expensive.
Yeah. Yeah.
Now, Westinghouse also marketed the BP10 as well. I have a Westinghouse version of the BB10. It's exactly the same in appearance, etc., but it has a Westinghouse name. I don't know the model number offhand.
That's okay. Not to be outdone, Zenith made the 4K 600, which was also a version of that radio. Because Zenith would never do anything that and to not embarrass General Sarnoff.
So just a fun fact for you is my grandfather bought one of those radios new, and it's still in my mom's basement.
Does it still have the 67 volt battery in it?
No, that got taken out years ago, so it wouldn't leak.
Oh.
Okay, well, thanks, Matt, for that excellent show and tell. You know, Matt, that could be bumped up to the presentation category. You know, I think you did a really great job on that. So thank you very much for that, Matt. Anybody else have a show and tell?
Yeah, I've got something.
Yeah.
Recent project I just completed is I always wanted an ESR meter to try to evaluate some of the electrolytics. And I looked online, started searching around different, ways people approached it. And I based this on a one called a 5-transistor ESR meter. It's up on one of the radio repair sites, but I enhanced it a little bit just so I could tell when the batteries were going low. And just to be quick, it operates a lot like the ohm meter in a VTVM. You flip it on, you'd connect the two leads together and zero it, and then you'd go and measure across the cap, say on a board like this. Got a bunch of small lytics on there and a power switch. It's essentially a switching power supply, and it works quite well. It was kind of fun to put together, and it stretched some of my abilities a little bit. I actually used it as an excuse to try and lay out a PC board, and it mostly works. I was able to use most of the board, but it's a prototype. So, but yeah, that's just show and tell. It's and it works. That's the fun part.
Yeah, that's very cool, Michael. I think that's a great project, and it's something everybody that works with capacitors could take advantage of. Any questions for Michael? Any other show and tells? Okay, well, if not, I have a show and tell, and let me get that going here. Anyway, what I'm going to do a show and tell on is this little light bulb here, which is an LED light bulb, and it's basically an LED substitution for a number 47 light bulb, and that's what my show and tell is about. So let me try this again. There we go. Okay, so what I did is I got really excited that, hey, I could buy this LED replacement, and I could put it in my the Zenith black dial radio I was working on, and not have to worry about the heat and all that stuff. And this one slide kind of says it all, in that these are great little things if you need to put a light bulb in a piece of equipment that operates, I would say, above 10 volts. The 6 volts of my Zenith black dial, the LED light bulb is just not that bright. That's kind of the bottom line here. But if you are using incandescent bulbs in test equipment where you're looking at the end of the bulb, it would probably work okay at 6.3 volts. Or if you have a radio that's using a filament voltage of 12 volts and it's got a dedicated tap for the indicator bulb, these would work great. They are not to be used in applications where the lamp's current is part of the tube's filament or plate current, like in an AA5 radio where they have a tap on the rectifier tube. That's not what these are for. So my show and tell here is just basically to say that I tried these out and it didn't work, but you might find a use for them, and they're kind of expensive. They're like $6 a piece. You got to buy 5 of them. They come in all different colors and all that. And then what I did is I tore it apart, and let's see if I can find. And then I made a comparison here. Here you can see a picture I took with a piece of cardboard between them, and you can see how the number 47 lamp just lights up the whole area and lights up the bench, but this other lamp just doesn't do it at 6.3 volts. I wouldn't recommend using them inside of a radio unless you're looking at the end of the bulb. So I took it apart. They're well built. Inside here is a single LED bulb and a full wave bridge, 4 separate diodes and a couple of resistors. And so it's a well built thing. And if you could get the manufacturer to put in a lower value resistor, they'd work great at 6.3 volts. But so that's my show and tell. If you're interested in these part numbers, I can put them out on the chat window. But that's that.
Too bad they're not bright enough for dial illumination in the Zenith.
Yeah, Larry, you had to go through some serious trouble and modifications to get the cooling for those bulbs. But yeah, it's a problem I've seen in some radios that, you know, the heat will warp some aspect of the tuning dial. Okay, any other show and tells today? Well, if that's the case, then we will move on to the next section, which is our items wanted, items for sale. Tom Kleinschmidt usually heads this up, so I will turn it over to him.